Good morning to all of you, dear students. Today we are going to discuss a session on limit. For that I am giving you self-learning material. After completing this self-learning material, you will be able to understand the concept of epsilon delta definition of limit, know about the epsilon delta definition of infinite limits, can also determine the existence of limit of given function, calculate the limit of the given function. I am providing you CAIM. CAIM is Computer Assisted Instructional Material. With that material, we will start from the concept of approaching, move on formal definition of limit and infinite limit, and one will also be able to calculate the limit of the given function. Before discussing on the session of limit, we have some instructions. Read the instructions very carefully. This material resembles a test, but it is not a test. It is developed in such a way that you can learn all by yourself. But it is not to be just read like book. You have to work through it. You should use your paper pen. The material is divided into sections called frames. Each frame has its own number. A question is added in the end of each frame for better understanding of the concept. Option with green ink is its answer. Problem for this session will be discussed after 7 days, and test of this session will be held after 15 days. So get ready for the discussion and test. First of all, I am going to start first frame entitled approaching. What do you mean by approaching? Approaching means something which cannot be worked out directly but can be seen what it should be as get closer and closer. So for example, you are given a function f of x square which is equal to x square minus 1 divided by x minus 1. When you put x is equal to 1 here, you will find it is 0 by 0. When you put, but if you get 0 by 0, then it will create the difficulty for you. So instead of trying to work it out for x is equal to 1, let us try approaching it closer and closer. Let us take 0.5, then you have the value 1.5, then 0.9, 1.9, and so on. When you put 0.999, you will have the value 1.999. That means what? That means whenever x approaches to 1, the given function x square minus 1 divided by x minus 1 gets close to 2. Now try from the other side. F of x is equal to x square minus 1 divided by x minus 1 by putting x is equal to 1.5. Whenever you put x is equal to 1.5, the given function gives the value 2.5. When you put x is equal to 1.1, it gives the value 2.1 and so on. You will see when you put putting so on, and finally when you put 1.00001, the value is 2.0001. Now we can see that as x gets close to 1, then the given function x square minus 1 divided by x minus 1 approaches to what? That is 2. That is the meaning of approaching. Now for example that you have taken earlier, f of x is x square minus 1 divided by x minus 1. When we put x is equal to 1 here, answer is indeterminate. But one can see it is going to be 2 from both sides as shown in frame 1 as well as in frame 2. Now one wants to give the answer 2 but cannot. But the mathematicians say exactly what is going on by using the special word limit. That is, the limit of f of x is the value that f of x approaches as x approaches to c. It can be stated as the limit of f of x is x square minus 1 divided by x minus 1 is 2. As x approaches to 1, here c is what? It is 1. and is written in the symbol as limit x tends to 1, x square minus 1 divided by x minus 1 is equal to what? It will be 2. From both sides the value is 2, then that is the right answer. Now come to the next slide. Now I am going to define the limit where the function is defined in some interval containing that point, but may or may not be defined at itself. Let f of x approaches or get close to L as x gets close to A. That means what? Limit f of x is L or f of x tends to L as x tends to A. It means what? The L is what? What will be here? L is the limit of f of x and written as limit f of x is equal. So answer is what? This is L. Now next, main topic that is in your syllabi, that is epsilon delta definition of limit. Now let us take f be the function defined in the neighborhood except possible at A, then real number L is said to be the limit of f as x gets close to A. For any epsilon greater than 0, however small, it may be there exists delta greater than 0. This symbol is delta and this symbol is epsilon. So that f of x minus L is less than epsilon whenever modulus of x minus L lies between 0 and delta. That is what? F of x lies between L minus epsilon and L plus epsilon, and x lies between in between the union of open interval a minus delta A and A plus delta. Now correct it that will be removed. It will be L plus epsilon. We write limit x tends to A, f of x is equal to L, or it can be written as whenever x tends to A, f of x tends to L. Now let us check it with the help of figure. X tends to A. This difference is denoted by the symbol delta, and this difference is f of x minus L. Corresponding to that point, you will have the value of f of x here. Corresponding to that point, you will have the value from here. For that, you will have the value. Now that difference is epsilon and that difference is delta. Now if there is relationship between that epsilon and that delta, then you will say the function tends to L. That function tends to L as x tends to A or C, whatever the number. It is 1, 0, any number x tends to A or C, like this. Now, I have described very beautifully manner when limit x tends to A. X tends to A means that what? That modulus x minus is less than delta. And for that difference, it is when you say limit that tends to A, that means that absolute difference f of x minus L is less than epsilon. Now, here f of x is defined in deleted neighborhood of A. Now, try to calculate the relationship between epsilon and delta, because if there is a relationship between epsilon and delta, then we will say the limit exists. For example, we take limit x tends to 3, 2x plus 4 is equal to 10. Now, as per definition, I have to take f of x minus L. Now, f of x is what? F of x is 2x minus 4. L is what? 10. Put all these values here. Now corresponding here, it is x goes to 3. Here you will put x minus 3 less than delta. Now solve it. You will see the tip for you is that here must be like this. It may be 2 times divided by, or you must have some type of like this must be here. So you can describe the relationship between epsilon and delta. Here you see, if I put twice of delta equal to epsilon, can I put? No. If I put it is epsilon, it means epsilon is equal to delta by 2. No. Is it equal? No. It means epsilon is equal to twice of delta. That green answer. There are so many possibilities you can say कि मैम आपने epsilon delta के बराबर कर दिया है. No. Here it is twice of x minus 3, here it is x minus 3. Here you are taking x minus 3 less than delta. So twice of x, the relationship is what? Epsilon is equal to twice of delta. When you do twice of this, then it will become the epsilon. Hence there is a relationship between epsilon and delta. So the given function 2x plus 4 tends to 10 whenever x tends to 3. As you done in plus 2 level, you know when left hand limit is equal to right hand limit. By definition, I am going to define a function f is said to tend to limit L as x tends to a from the right or from above if for each epsilon greater than 0, however small, there exists a delta greater than 0 such that modulus of f of x minus f of x minus L is less than epsilon. Here the interval is what? X lies between open interval a and a plus delta. And if I say the right hand limit does not exist, it means modulus of x minus L is greater than epsilon. F does not tend to L means f of x minus L is minus L greater than epsilon. Now similarly you can define the left hand limit. For left hand limit, the difference will be here, modulus of x minus L is less than epsilon, it will be the same. But the x lies between the open interval a minus left side, a minus delta and a. So when you have to define f does not, you will say that x belongs to a minus delta and a for what? Modulus of x minus L is greater than equal. मीन्स ग्रेटर देन इक्वल टू एप्सिलॉन है तो आपकी लेफ्ट हैंड लिमिट नहीं एग्जिस्ट कर रही, बट अगर f of x minus s less than epsilon है तो लेफ्ट हैंड लिमिट एग्जिस्ट करेगी. And you also know when left hand limit is equal to right hand limit, then limit exists. Now I am going to define the necessary and sufficient condition for the existence of limit as x tends to a. F of x is that when both left and right hand side limit exists. That means what? F of x tends to L as x tends to a if and only. This symbol is for if and only. Necessary and sufficient means if and only. For any epsilon greater than 0, however small, there exists delta greater than 0 such that a modulus of f of x minus L is less than epsilon when x lies between, is it? No, that will be the third portion. The modulus of f of x minus L is less than epsilon whenever modulus of x minus A lies between 0 and delta. It means what? Because delta is greater than 0, no? It means f of x lies between L plus epsilon and L minus epsilon. Now when you know it very well, whenever limit exists, it is always unique. If it means if you have L1 and L2, two limits of the given function, it will be always equal. Means L1 is equal to L2. Now we will discuss some questions. Show by definition that this. So what you have to do. Now f of x is 3x plus 4. Put that value here and solve it. You will see earlier you have seen here was twice and here it is thrice. It means what is the relationship? Delta is equal to epsilon by 3. Now do yourself, use your paper pen and solve each and every concept, every step. Now next I am taking another example for trigonometric function in which you have to prove limit x tends to a and cos x is equal to cos a. Put the value of f of x, cos x minus cos a, solve it. You will see it will be equal to less than equal to this. How it is? Because you know the value of sin x lies between mod x, as well as you know also know the value of modulo sin x is less than equal to 1 is sin x lies between -1 and 1. तो अब प्रश्न ये उठता है कि मैं इसके लिए 1 लूँ या इसके लिए x लूँ. क्यों मैंने इसके लिए लिया? Because whenever x minus, I have to define the relationship between epsilon and delta. Here it is x minus a, so I have taken this portion, this property for that and this property for that. That's why it is less than equal to twice of this. Now it is very much clear. What is the relationship? Here it is. What is the relationship? Is there any relationship between that or not? Twice of this 2 will cancel, delta is equal to epsilon. That is the right answer. Now, earlier we were discussing for the limit for finite limit. Now I'm going to discussing the epsilon delta definition for infinite limits. A function f is said to tend to plus infinity as x tends to a if for each k, however large it may be, there exists a delta such that greater than 0. This is important. F of x is greater than equal to f of x is greater than k whenever modulus of x minus a is less than delta. तो इसको कैसे डिफाइन करेंगे? लिमिट x टेंड्स टू a f of x इज इक्वल टू इंफिनिटी मींस जो x टेंड्स टू a उसके लिए तो वही मॉडुलस x माइनस a आ रहा है, बट x f of x टेंड टू l था तो हमने मॉडुलस ऑफ f x माइनस l लेस देन एप्सिलॉन किया, बट यहाँ पर क्या है कि f of x टेंड्स टू इंफिनिटी है तो उसके लिए आएगा f of x इज ग्रेटर देन k, और अगर ऐसा ना हो तो क्या आएगा? f of x इज लेस देन माइनस k in order to show नेगेटिव माइनस इन्फिनिटी के लिए क्या आएगा? f टेंड्स टू माइनस इन्फिनिटी के ऑपोजिट साइड चला जाएगा ना, देन इट विल बी f of x is less than minus k. Now next I am going to show using the definition limit of 1 over x square whenever x tends to 0 is infinity, and you already know that for number 0 that is infinity, but I have to prove here by definition for that as x tends to 0 x becomes smaller and smaller. If x square becomes smaller and smaller, that means 1 over x square becomes larger and larger. It means what? If k is any positive real number, however large, then 1 over x may be then also. Therefore, 1 over x square is greater than, here is some mistake, you can rectify. 1 over x square is greater than k if x square is less than k. That means what? 1 over x square, that is the same thing, repeated. Modulus of x, you can take its modulus of x is less than 1 over, if x square is less than 1 over k, it means modulus of x is less than 1 over under root k. Now you have to define what should be taken here. Taking what we have to take for 1 over under root k, this 1 over under root k. We have 1 over x square is greater than k if modulus of x is less than delta. It means क्या है? Modulus of x is less than delta means x minus 0 is less than delta. तो a क्या हुआ आपका? 0. तो यहाँ a की जगह क्या हो गया आपका? 0. अब क्या है? यहाँ से फंक्शन की वैल्यू क्या है? 1 over x square. Replace it by f of x. Now it is very much clear. a की जगह आ गया 0 और ये डेफिनेशन क्लियर हो गई, तो इसका मतलब लिमिट x टेंड्स टू 0 1 over x square is equal to limit of the given function tends to infinity whenever x tends to 0. ठीक, तो फिर हमने अब प्रश्न ये उठा कि हमने डेल्टा क्या लिया, ये ना, तो एप्सिलॉन हमने लिया 1 over under root k is 1 over under root k, this 1 over under root k is equal to delta. Okay. Now the last example, let us take, that is very important example. Let us take f of x is equal to 0 if x is rational, it is equal to 1 if x is irrational. So we have to check whether the limit f of x exists for any real number a. Now, question may be in different manner also. Examiner may put here 1 and put here 0. The answer will be almost same. Only understanding concept must be very much clear to you all. Let a be any real number in the interval a minus delta and a, open interval. If whenever you take open interval, there lies infinitely many rational and irrational number. It means when you take rational, it will be 0. Mean open interval, there are infinitely many rational and irrational number. It means क्या होगा कि जब rational number की टर्न आएगी तो वो देगा वैल्यू 0 और जब इरेशनल की आएगी तो वो 1 देगा। बट अगर लिमिट एग्जिस्ट करेगी और 0 इज नॉट इक्वल टू 1, और अगर लिमिट एग्जिस्ट करे तो इट मस्ट बी यूनिक, हेंस द लिमिट डज नॉट exist. Now, next line, limit of f of x as x tends to infinity or x tends to minus infinity. For that, a function f of x tends to L as x tends to infinity for the given any positive number epsilon, however small, there exists a positive number k. मीन्स क्या है कि यहाँ पर अब क्या उसमें क्या था कि यहाँ पर इन्फिनिटी टेंड कर रहा था और यहाँ पर एक भी था। अब क्या है कि यहाँ तो लिमिट एग्जिस्ट कर रही है और यहाँ पर इन्फिनिटी है, मीन्स एक्स तो इन्फिनिटी को टेंड कर रहा है पर फंक्शन एक लिमिट को ले रहा है, f of x tends to L, x tends to infinity. So thus in order to show that f of x tends to L as x tends to minus infinity, then what will happen if for some given any positive number epsilon, however small, there exists a positive number k depending upon epsilon, such that because limit यहाँ exist कर रही है तो यहाँ पर अब डिफरेंस लेस देन एप्सिलॉन होगा और यहाँ क्या आएगा ये बताइएगा। यहाँ के लिए तो आपने लिया x इज ग्रेटर देन k, तो यहाँ जब आप माइनस इन्फिनिटी के लेंगे तो आप लेंगे x इज लेस देन माइनस। अपनी कॉपी पर करके देखना अपने नोटबुक पर, तो आपको ये कंसेप्ट बहुत अच्छे से क्लियर होगा कि, और आपको बहुत अच्छे से क्लियर भी करना है कि इन्फिनिटी और माइनस इन्फिनिटी में कैसे एक तरफ इन्फिनिटी लिखिएगा एक तरफ माइनस इन्फिनिटी, एंड यू विल गेट क्लियर वेरी वेल. Now, thank you for learning. Get ready for discussion and test. Bye-bye.